let's understand algebraic expression. Let's read the definition first. A combination of constant and variables. A combination of numbers and letters, right? So a combination of constant and variables connected by operations, means when it is connected by signs like plus, minus, multiply or divide, is called as algebraic expression. For example, if I take 3x plus 4y minus 2y, this is an algebraic expression. 3 is my constant, x is my variable, 4 is my constant and y is my variable. So now when you have all these constant and variables together and they are connected or say separated with plus, minus or say multiply or divide, then we call them as algebraic expression. So 3x plus 4y minus 2y is an algebraic expression. Similarly, 2a plus 6b is also an algebraic expression. Now, let's move on to the various types of algebraic expression. Okay, now here with your types of algebraic expression, just read the examples I have written here. I have minus 3y. Here I have 2.5x. Now the second example, I have 5x plus 3z. And here I have a squared minus b squared. In a third kind of example, I have a plus 2b plus 3c. And here I have a squared plus b plus b squared plus c plus ac squared. All these children are algebraic expression. But if you see here, I have only one term, right? There is only one term. So this is called as a monomial. This algebraic expression is called mono. Mono stands for 1. So this is a monomial. Say that 2.5x is one term. So again, this also is called as monomial. Now here if I see, there are two terms here. I have 5x which is separated with plus, and then I have 3z. There are two terms here, and that is why this is called as binomial. This algebraic expression has two terms, so it is called binomial. Here again, two terms separated with minus, so again it is called as binomial. By now, I'm sure you have understood this. How many terms do we have here? Yes, count and tell me, children. We have, yes, we have three terms. There is A, there is 2B, there is 3C, and it is separated by two different pluses. One plus here, one plus here. So this is called, if this is mono, that's bi. What do you think this should be? This should be a trinomial. Tri stands for 3, isn't it? And same way, I have another example here. A squared b plus b squared c. Needn't be all the time that I need to put a plus here. This also could be minus. But I have three terms. And that is why this is called as trinomial. Let's move on to your exercise now, 13a. Now children, question 1 from your exercise 13a. Identify the following expression or algebraic expression. Let's take the first sum. I have 7b squared into a cube b. Children, when you're dividing your terms, we only see plus or minus and not multiply. So when you have 7b squared into a cube b, my answer actually here is 7b squared a cube b. So this becomes one term. Did you understand? This is one term. So that is why this is a monomial. Did you understand? This is just one term. So this is a monomial. Did you get it? Have you understood? Alright, now let's move on to the second sum. Now in the second sum, if you see, I have a plus. So there are two terms here. Alright, there are two terms here. So this becomes a binomial. Have you all understood? Is that clear? So third one, again children, there is division. Please remember, whenever you have multiply and divide, the whole thing becomes one term. Like here, this is 3x squared upon p. This is just one term. So this is called a monomial. This algebraic expression is a monomial. So the first one term. So it is a monomial. Second one, it is separated with a plus. Two terms, so it's a binomial. Third one, it's division, so it's one term, so this is monomial. Now fourth, now children, here if you see, I have plus and minus 2 and upon 7. Actually, what does this mean? This means 3a upon 7 plus 2b upon 7 minus 5c upon 7. Correct? This denominator is for all the three. So, now this has been divided with plus and minus. So, how many terms do I have here? There are 3 terms. So, what is this? This is a trinomial. Have you all understood? Now, let's move on to the fifth one. This I don't need to say. It's very clear. I have xy plus yz minus zx. I'm sure you have guessed by now. What is it? This is a trinomial because it is separated with plus and minus. And the last one again. Now children, be careful. I have ax squared, correct? It is separated with a plus and I have a multiply. Now, if I solve this, what do I get? I get it as ax squared plus bx plus y squared, bx into y squared. So this, my answer becomes bx y squared. Let's just repeat it. I have ax squared plus bx into y squared. I said when we separate the terms, we only see plus and minus. So this is ax squared. It is separated with plus. So bx into y squared gives me bx y squared. See here, 7b squared into, this became one term. Similarly here, this becomes one term. So, how many terms do I have? I have only 2 terms here. There are only 2 terms separated by a plus. So, this is a binomial. I'm sure you have understood. Let's move on to the next question. Question 2. If you read your question, what does it say? Write down the numerical number and literal, the letter, coefficient of the Correct? So 4 is multiplied to x. So I can say 4 is the coefficient of x. So that becomes my numerical coefficient. And if I ask you the literal or the variable, then I would say x is the coefficient of 4. So if we see the first sum here, I have minus 2 p cube q squared. Right? Now what is my numerical coefficient? My numerical coefficient is minus 2. Correct, children? And what is my literal coefficient? The literal coefficient will become p cube q squared. Have you all understood? Is it clear? Okay. Now, here the number value if I take, that is minus 2. The literal coefficient is p cube q squared. Now let's come to the third sum from your book. I have minus 3ab squared upon 2. What is it? Minus 3ab squared upon 2. Now here, if I ask you what is the numerical coefficient, the numerical coefficient will be minus 3 upon 2. Have you all understood? And what becomes the literal coefficient? The literal coefficient is ab squared. Have you all understood? ab squared. Same way here, if I ask you the numerical, the numerical coefficient is 2 and the literal coefficient is ab upon c. I'm sure by now you've understood what is the meaning of coefficient. Let's move on to the next sum. Your next question is identify the like terms. We'll come back to that a little later. First, let's understand what are like terms. Terms having the same literal coefficient. Let's forget all that. Let's come to the example. Terms having the same literal coefficient. What do I mean by that? Now when I see something like this, now let's take this as 1x squared. 1x squared minus 2xy plus 3y squared plus 5y plus 3xy minus 6x squared. I have different letters with numbers. Now this, if you see together, these all are in unlike terms. Okay? These are all unlike terms because I have a mixture of letters in this. Now if I need to group them into like terms, what would I do? I have 1x squared minus 2xy plus 3y squared plus 5y, correct, plus 3xy minus 6x squared, correct. Now I have grouped them. So these two become like terms. Again, these two become like terms. Those are separate terms totally together. There is 3y squared, there is 5y. These two are like terms. Why? Because I have x squared here, I have x squared here. So this is a like term. I have xy, I have xy. So this is another like term. I have y here, I have y here. But there is y squared and there is what? These do not become like terms. Let's move on to the sums from your book. Alright? Now, your next question. Question 4. Identify the like terms. The first sum. Now, they said identify them. So, which have the same alphabet if I take a squared minus 2a squared. Right? So, a squared and minus 2a squared are the like terms here, isn't it? Then, let's move on to the third sum. Now here children, be careful. If I see minus 2xy squared be careful, minus 2xy squared. Then where do I have here again x and y squared? Here. The letters may be interchanged, but make sure they have the same exponents. Like here, I have minus 2xy squared, and again this is 5y squared x. These both are like terms. They both have the same alphabet or the same exponents. Minus x y squared y squared. Clear? Then if I take this is x squared y. Now here again it is totally different. This is x squared z. So only these two are your like terms. Now let's see here. We have quite a number of terms, isn't it? So let's start here. I have a, b, c. Then I have a, b squared, c. Check these children. A, c, b squared. So again this comes here. A, c, b squared. Right? A, b squared, c, c. It doesn't matter if they are interchanged. These become your like terms. Then let's move on to the next term. I have c squared ab. Nothing like. Then I have here b squared ac. Again this comes here. b squared ac. Children, see. Why do they become like terms? Because b squared, b squared, b squared. A. C here, C here, C here. Yeah? So these are all like terms even if they are interchanged. Next, I have a squared bc. Nowhere. A squared bc. Then I have c ab squared. Nowhere again I get to see this. c ab squared. Do we have it here? Yes, we do have it here. So it is here. C AB squared. Correct? Let's read your question. ABC, AB squared C, ACB squared, C squared AB, B squared AC, A squared BC and C AB squared. So, which are my like terms which I've got? I've got 1, 2, 3, 4. Correct? Never mind even if it interchanges. Just check. A here. B squared, B squared, B squared, B squared. C here. Understood? So I'm sure by now you've understood what are like terms. Let's move on to the next question. Alright, your question 6 from your textbook. Identify the polynomial and write the degree. First, let's understand what are polynomials. An algebraic expression. You know what's an algebraic expression? You've learned monomials, binomials, trinomials. In which the variables, in which the letters have only non-negative integral power is called a polynomial. Let's understand what does this definition mean. Now let's come back to your question 6, the first sum. 2 more 3, x to the power 4. Now this is your degree, children. X to the power 4 minus 7x plus 15. Now this algebraic expression is a polynomial. Alright? This is a polynomial. And you say the degree here, we take the highest degree. Now this is x to the power 4. When there's nothing and you just have x, it means x to the power 1 or just 1. So x to the power 4. So your degree is 4 here. So this is a polynomial. Now children, here if I see this, 8x squared plus 3x plus 6 root of x, that means x to the power half plus 1. Now this is not a integral part. So 8x squared plus 3x, 8x squared plus 3x plus 6x to the power half, this becomes plus 1. This is not a polynomial. Okay? This is not a polynomial. Okay? Now again, if I take this sum, I have 5x squared minus 2. Children, this x when I bring, this becomes x to the power, see, when it is down, it is x to the power 1. We read these kind of sums in your exponents. So when I bring it on top, it becomes minus 1 plus 7. So I have a negative integral part. So this again is not a polynomial. This is not a polynomial. Okay, let's do a few more sums from this question. Okay. Questions. The sum 4 from question 6. Same thing. Identify the polynomial and write the degree. So I have 9x squared y squared minus 3xy squared plus 5x squared y minus 6x. Now you know this is a polynomial, right? And if I ask you the degree here, remember the highest exponent becomes your degree. I have x squared y squared here. There is 2 and just 1 here. 2 plus 1, 3 and 1. So here the degree will be 4. 2 plus 2 gives me 4. Correct? Now let's go to the fifth one. Again 6p to the power 4 minus p cube q squared plus p cube plus q to the power 4. This again is a polynomial. Right? This is a polynomial. And the degree here, what did I say? The degree will be the highest exponent of your variable. So I have 4 here. 3 plus 2 gives me 5. So this is my degree. So my degree here is 5. Now look at this question, children, and tell me, do you think this is a polynomial? What do you say? Yes, this is not a polynomial. Why? Because I have a squared below here. This gives me as ab squared minus 7a to the power minus 2. This is a negative integral part. Therefore, this does not become a polynomial. I hope this is clear with you, children. And with this, I finish with your exercise 13a. Question 5, please don't do it. When I do the next chapter, that time I shall explain these things to you of how to put the algebraic expressions, how to generate these, or how to put them in alphabetical form. We will do it in the next chapter. So please don't do question 5. Please complete your exercise 13a, and if you have any doubts, you can come back to me. Thank you and see you later. Hi students, welcome back. Today, let's do something different from what usually you have done. Let's do algebra today, and this is for class 7. Now first, let's understand the fundamental concepts. That is, what do I understand, or what does algebra mean? Let's read it. It is a type of math in which letters and symbols are used to represent. Right? Okay. You are already familiar with expressions like 4x or say 4x plus 3y. Right? So, in algebra, you see symbols. Now, these symbols, I can divide them as constant and variables. Alright? Now, variables are also called as literals. Alright? Now, what is constant? Constant in algebra is the numerical value. For example, if we take 4x, 4 is your constant. It is the number value. And x, the letters in an expression are called as variables or literals. So for example, if I take the same 4x, x is the literal or the variable. Have you all understood, children? Then I have 4x plus 3y. So 4 is your constant and x is your literal. 3y, if I take, 3 becomes the constant and y is your literal. If I say 6xyz, 6 is your constant and xyz is your literal. Next, let's try to understand what you mean by algebraic expression.